Well, good evening. Welcome to Space Oddities. How is everybody? Hope you're all well out there. Bit thin on the ground tonight. Please think your commiserations for Lou, who had a double COVID and flu jab yesterday, which has made him very poorly. So he's not with us tonight. Rachel, of course, is looking after baby Isaac. Michael is otherwise engaged at an Astronomy Society meeting. But we're delighted to welcome the usual rabble here. Roger, hi Roger, hi Dad,
Hello.
hi Bernard.
Hello.
And we're
Hello.
extremely delighted to welcome our special guest for this evening, Sam Morrell. How are you, Sam?
Hello, everyone. It's an absolute pleasure to be with you this evening. So thanks for having me.
Oh, it's our absolute pleasure. Now, we're going to be talking to Sam about two things, really. Gravitational wave and his work with astrophysics and light pollution. Sam is at Exeter University and doing all sorts of useful work at Exeter. And we're delighted to welcome you to the show, Sam. We'll have a chat with you a little later, if we may. And I'm sure that we've got some interesting stuff to learn from Sam. Hello, everybody. I'm looking in the chat. Hi, Kev. Hi, Gerard. All the usuals are here. Hi, Astro Matt. Hi, Heidi. Hi, Derek, etc., etc. So welcome to all our regulars. And if it is your first time watching Space Oddities, you are most welcome. And the most important thing you can do for us, if it's only just a little thing, is to like and subscribe. Of course, hit the subscribe button, like the video, and hit the notification bell so that you're always aware of all of our latest videos. I'd like to thank Daz, and Michael, of course, but he's not here. I'd like to say thanks to Daz and Michael for joining me on Sunday for our live coverage of the return of the Osiris-Rex asteroid.
Great fun.
That was a good show to do. And that was a bit nail biting, wasn't it? Because we thought at one point that the parachute hadn't opened. Yeah, that was a bit nail biting, but luckily it had. And the sample is now safely stowed, safely nitrogenized, and is being analyzed. And of course, those samples will be sent around the world to the world's scientists for analysis. And of course, that will take years because they're working, really nearly at the subatomic level with some of those tiny particles. Yeah. They've got to analyze them and find out exactly what they're made of. So that was a great day on Sunday. Of course, we've got a few more launches. Great launches coming up that we'll be covering. Don't forget, on October the 5th, it's the launch of Psyche. The spacecraft launched the asteroid of the same name, which is a metal asteroid, unlike anything we've seen before, which may be the core of an ancient planetesimal or something else entirely. We don't really know at the moment.
Gosh, Andy.
Yeah.
October, this is just in a few weeks. I can't believe where time's gone. I remember we were talking about Psyche, how it was delayed, and everything.
I know.
And now it's going to be
next week. It's next week.
Yeah, because as I was said on Sunday, NASA, there's 3 or 4 events happening in the next few months. We've got we started with asteroid-based events. We had the Osiris-Rex on Sunday. There's the DART. Apparently, it's 1 year anniversary of the DART mission.
I can't believe that either.
No, exactly. Where's time gone? We got the launch of Psyche, and what was the other one? There was another one, wasn't there? I'll get back to you on that.
Yeah.
But there's 4 things. They're calling it asteroid autumn.
Yeah. So don't forget, stay with us on Space Oddities. We'll be covering all these momentous space events live as they happen. And, we'd love you to share those moments with us. Something to tell your children and grandchildren, obviously. I saw Daz on Space Oddities. I mean, what more do you want out of life?
Yeah.
Yeah, wow. Absolutely.
Wow.
So anyway, let's move on so that we can get back and have a chat with Sam, which I'm really looking forward to. I don't want to leave Sam out there in the cold for too long. You're welcome to chime in at any time, Sam. If you want to insult us or threaten us or whatever, then do whatever.
Never insult.
Let's move over to. Before we do that, can I just say thank you to those of you who bought us coffees recently. Much appreciated. It helps us keep the ship sailing, as it were. So thank you very much for your continued generosity with that. If you would like to support the channel by making a direct donation, you will see that there is a new button you can click in the chat, which allows you to make us a direct donation. And anyway, just thought I'd mention it. I think you get some sort of perk out of that, if I remember rightly. Something in the chat, some icon or emoji or something. But I'm sure you don't want that. I'm sure you give us some money. So so there we are. So anyway, it's called a super thanks if you pointed it with your mouse. So there we are. So let's move on, as is tradition here. The man who has his foot on the pulse of the eye of the universe, or something like that. How are you, Roger? Let's have a look at the night sky, shall we? What's up?
Well, why not? And so we will. Right, so we're now going into the last of September, into the start of October, which will mean... Yes. All right. Okay. Did you hear
somebody
that?
telling you to shut up already, Roger?
Yeah, somebody asked that Amazon advice I keep getting. So during the latter part of the week, namely Friday, is when we get the full moon, and this designation is the harvest full moon.
But we don't talk about them, do we? We don't talk about moon designations.
No. or super moons.
Or super moons.
You
Wash your mouth out.
Right. Anyway, so that's when that'll be happening on Friday. And I did manage to get out in a bit. There was a few clear skies, and this was 3 days ago when we were just past the first quarter.
Lovely, Roger. That's lovely. Another winner.
I did take one last night, but it was taken through the clouds and it was a bit misty, so not so good.
That's lovely. Oh,
but, we still got some sunspots on the go. We've got some activity there, and I think there is some more on the way round, but I've not caught any today. But
no, because I mean that little group of well, there's a couple of groups, but the group on the bottom right, I mean, how many sunspots are in there?
I don't know, but there I did count them up the other day, and there was about 41.
Wow, I mean that's going to put the average up at the end of the month, so it'll be interesting to see how that tallies with the cycle. Yeah, it'll be interesting.
Anyway, so we've still got the summer triangle dominating overhead, and it's now passing over. Now that we've got Saturn over and Jupiter up more regularly, and also following on the heels of Jupiter, we've got Taurus and the Pleiades.
Oh, good. I know. Well, of course, they're here in Spain.
And this screen is from 10 o'clock in the evening.
Yeah. Here in Spain, they've been up for a while, you know. I see winter a lot sooner than you do, unfortunately.
Yeah, so obviously when we get through the week, we're getting more. But on Thursday, I think when we got the full moon, or just after, we've got Jupiter and the moon quite close together, if anyone wants to take a photo opportunity of that.
Oh, that's nice.
Or the Jupiter, the moon, and the Pleiades. So that's quite good. Some rather blurry pictures that I took also last week of Jupiter and Saturn, but
I thought they were further apart than that.
Well, I have conjunctions in Sparkford,
exactly.
So it's a good photo opportunity.
Did you cross your eyes?
That's much closer than it was in the Great Conjunction.
As you can see. But Saturn has got a lot closer to Jupiter in size as well, so that's
impressive. Shrinkflation's affecting everything nowadays, isn't it? Including
yeah, that's right.
Anyway, so we've also got during the wee hours in the morning, which is about I've got this down at about 6:20 in the morning, just before things get too bright, for an opportunity to spot a low down Mercury, if you want to see that. Obviously Venus being up quite higher and dominating the morning sky as well, so that could be of interest if anyone should have the rare opportunity of a clear morning sky at that time of the morning.
Yeah.
But as you can see, as it progresses through the week, it does gradually sink down towards the horizon a bit more, unfortunately. But that's how we are. Oh, this was obviously from the James Webb regarding the oxygen in the atmosphere.
That's quite an amazing find, because that's CO2 on the surface that has probably come from the underground ocean. I think.
So yeah.
And don't forget the ocean in Europa contains more water than all of Earth's oceans put together. So that is quite a stunning amount of water. Yeah.
Yeah, and we can talk about this later on.
Yeah, we'll come back to that, because I've also got this this story in this week's news, so perhaps we can talk about it then.
Okay,
sure.
Right, I shall now lead on to part 2, which is the gallery from our usual regular suppliers of these wonderful, wonderful images.
Yeah.
And
what's Lee been up to? Well, what's he done this time?
Well, he's been out in the middle of the night, all these dodgy areas again, I'm afraid. This time he's been like painting a tree. That's his excuse, and he's sticking to it.
Right, yeah. We believe you.
Yeah.
This is not a graveyard this time.
But there was some faint colours of aurora left down in the dew build-up when the clouds rolled in.
Oh, okay. Let's have a look.
But there we go.
Oh, yeah.
But we do have a very clear view of Ursa Major above the tree.
You can see Alcor and Mizar very clearly.
Absolutely.
Yeah.
That's a nice shot.
That's a lovely shot, Lee.
Well, it's almost a bit like lavender in the foreground, or is that just the lighting?
Could be lavender, actually.
Looks a bit lavendery.
Yeah. Pity we haven't got smell-o-vision. We'd be able to tell easily.
Yeah.
Yeah.
Anyway, very nice.
Very nice.
As you can see in the corner there, on the bottom right, there is some wisp of colour of green and red from aurora as well.
From aurora, yeah.
Ooh, lucky him. Right.
The last week
and another one of our regulars, Jerry DeLay, with the Sol Nebula in Cassiopeia.
I don't know that one. Sol Nebula? I don't think I know that one.
Well, here's a picture of it.
Oh, lovely.
There's some colours.
Jerry does it again.
Yes, he does.
Isn't it part of the heart and soul?
There's a heart and a soul which are quite close together.
That's right. Yeah. I've heard of that. Yes.
That is fantastic. There's some detail in there, isn't there?
Look at the detail of that. That's excellent, Jerry.
Yes.
Well done.
Nice, yeah.
Anyway. And then we've got one from Sonia, which is a landscape over London with the moon.
Oh, yes. I saw this one from Sonia. Very nice.
Oh, that's nice.
Isn't it?
Yeah, got some quite interesting details.
I take it that's...
And I think we've got Jupiter in the top right-hand corner.
Oh, yes, that's right.
Oh, yeah, I can see it.
She's either in a hot air balloon or it's taken from the Shard, I think.
Something like that.
Or a drone.
Is that the power station over on the left there with those towers? They look a bit like it.
Oh, well, the two, what's the name? There is a football green at the front, and it looks like they're playing.
Probably. Oh,
yes. It's on the bottom left.
Oh, yeah.
Anyway.
Yeah, that's right. Well spotted, Daz.
Uh-oh.
Him again.
So we stop this now?
Yeah, just let's stop.
Okay. So
Roger, you've done it again. Yeah.
Well, I was trying to do some other bits and pieces. So I thought, what should I do now? And I thought, do some Pleiades. So there we are.
You've caught the nebulosity.
Not too bad.
Very well.
There's a hint of other bits all the way around it, but obviously needed more time on it to bring that out. But yeah.
Very nice. I prefer the other shots, to be honest.
Yeah.
I quite understand.
Yeah.
And then I've got one from my library of the M13 and Hercules.
Always a favourite.
Nice.
Yeah.
Very nice.
That's where the Arecibo message is on its way to.
Is it?
That's right. That's right. Don't think they'll get an answer.
No. Well, Arecibo's gone now, so it'll say this number is no longer connected.
Yes. Please hold the line call. We're trying to connect.
Just get.
Hey, Daz, that's like your internet signal going via the two phone towers in France.
In France, that's right. Yeah, the two dead ones. Yeah.
We found out Daz was having trouble with his bandwidth, Sam, and he and I tracked down where his signal was going from Shropshire, and it was going from Shropshire to France. to 2 phone towers that have been decommissioned or were otherwise unconnected, and then finding its way back to London to the server. So,
oh wow, that's impressive.
Right.
isn't it? Yeah. So
Right, you can switch my pictures off now.
Oh, okay. I'll turn you off.
Yes.
Okay.
There we are. Okay. Well, thank you for that. Thank you for that, Roger. As always, thank you, readers, or viewers, shall I say? I keep saying readers. Viewers, for your fantastic images, as always. If you would like to submit an image or more than one image to our gallery every week, because we do love looking at them and, we do admire your skills in producing those images, you can mail them to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. One image per email, please. And if you could entitle your emails image gallery or viewers gallery or something with the word gallery, and that'll make them very easy to find in the inbox when we do a search for them, or when Roger does a search for them, should I say. So so thank you very much. Keep them coming in, because this show wouldn't be the same without the viewers gallery every week, and we look forward to receiving them. And thank you so much.
Just to show how easy it is, I've just done a quick image of the Pleiades.
Just now
on my phone, from my backyard. So
you see,
it's easy.
Anybody can do it. Anybody can do it. And as we always say, we're not just interested in deep sky and planetary stuff. We like images like the one of Sonia did with the London with the moon over it. Skylines, anything like that. We love anything with the sky in it, because we're weird.
And Lee in the undergrowth.
So absolutely. And we know that people like Lee are out in the early hours of the morning snooping around some very strange and weird places to get these photos. So we do appreciate the effort that takes as well, and the risk of being arrested by the police. So there we are. Yeah, I think we've all been there, haven't we? I know I have.
And Andy, should we just move on?
Sorry. Yes, let's move on. Anyway, let's talk to Sam. Sam Morrell from Exeter University. Sam, would you like to sort of officially introduce yourself and tell us a bit about yourself?
Yeah, sure. So I'm Sam Morrell. I am a researcher who works both in the astrophysics group in the physics department at the University of Exeter, as well as working in the Environment and Sustainability Institute in Cornwall.
Right.
And so I'm trained as an astrophysicist. My kind of specialist subject, I guess, is star formation, stellar evolution. So seeing the Pleiades just then in those beautiful pictures brought me right back to writing my thesis on low mass stars in the Pleiades. One of my favorite clusters, beautiful benchmark cluster. And so I'm at the moment I'm employed as a researcher to work on a cross-disciplinary project, applying astrophysics techniques to better understand light pollution and model light pollution. So that's kind of my job.
Sam, could I just interrupt for 1 second? Your volume's gone very low again.
Oh dear. Okay. How's that?
Okay, that seems to be a bit better. Yeah. Sorry, you were saying.
Okay. Yeah. Sorry about that.
That's okay.
But yeah, so I'm at the moment I'm working with in a cross-disciplinary team to apply basically astrophysics techniques, both computational and methods, to understanding and modeling light pollution in our cities and rural environments from an ecological perspective. But I'm here today, I believe, to talk about gravitational waves and CHIRP, which we've just recently taken on at Exeter. So that's kind of a little bit about me.
Right.
What do you want to talk about, I guess?
Well, let's start with telling our viewers who are not familiar with it exactly what CHIRP is.
Okay. Yeah. Of course. So CHIRP is a web app and phone app for basically anybody who wants to follow the LIGO, Virgo, KAGRA, gravitational wave alerts. CHIRP is a web app and a phone app that lets you basically see all of the alerts as they come in live, listed in a nice interface. You can see basically where they appear on the sky, all the information about them. And when we've got the phone apps launched again, it will actually send you push notifications to your phone of all the latest gravitational wave alerts, and then you can follow up on them in real time. So that's basically what CHIRP does.
Sam, can I interrupt you? How do you spell CHIRP actually for our audience?
CHIRP is just spelled CHIRP, and it's, if you want to see the web app, it's, let me see if I can remember this, chirp.research.exeter.ac.uk.
Right. Okay. We will put that in the description of the video for our viewers. Yeah. So I've actually just got a couple of questions myself, if I may, about CHIRP.
Go ahead.
Because it was originally at Birmingham, wasn't it?
Yes. So do you want me to give you a bit of history?
Yeah, please. That would be interesting.
Give you a bit of context.
Yeah.
Okay. So CHIRP, the origins of CHIRP date all the way back to, I think, 2017 or 2018. And the project started with a very good friend of mine and a colleague who was at the University of Birmingham, called Dr. Sam Cooper, and his job at the time was working on the seismic isolation systems for the LIGO observatories, so the 2 observatories in the States. So he had young cousins at the time. And they kept on asking him, they were really enthusiastic, and they said, "Oh, Sam, what do you do for your job? We want to know more." And he couldn't think of a nice way of kind of explaining it and making it accessible to them. So when he heard, I think it was at a conference sometime there, that they were publishing the alerts or the super events as they came off of the detectors live via the gamma ray coordinates network, he thought, this is a great opportunity for me to actually put together a little app for helping basically people access this incredible source of live astronomy as it came off of the detectors, and make it as accessible as he could, so that his young cousins could actually see and be engaged by the work that he was doing.
Right.
So that's essentially, that's how it started. Was a few PhD students, myself, Dr. Aaron Jones, who's at Osgrav and in Australia at the moment, and Sam, we basically just sat down one evening and just kind of hacked together the very basic prototype of CHIRP. And as they say, the rest kind of came from there.
Right, I see.
Yeah.
So why did it move from Birmingham to Exeter then?
Well, as so many things have done, the pandemic kind of put a big stopper on everything. So LIGO, the LVK consortium, stopped observing in the previous observing run. All of the team who were working on the app at the time, who were at Birmingham, left Birmingham and moved on to other things, both inside of academia and outside of academia. Right. And it came to a point where we just were like, it seems unfair to have Birmingham kind of hosting this app when nobody who maintained it is there anymore. Right. So and there was a real risk of the server being shut down, and so this was I don't know, probably about 6 months ago. I had LIGO, the LIGO EPO team, the Education and Public Outreach team, reaching out to me via email saying, "Is CHIRP going to be ready for 03?" And a load of other people reached out via email, and I knew, okay, we have to find a way to make this work. We have to find a way to keep this app running, because so many people have kind of basically got used to having it there and were really invested in
absolutely.
Yeah. We were desperate to see it return.
We were desperate to see it back, because it got to be a habit with me. First thing in the morning, what do? Wake up and check CHIRP. I mean, as you do.
I do, but I didn't think that was what everyone did. It's nice.
You're not alone. I mean, one of the things I have noticed, because the LIGOs, the 2 LIGOs in America, they've just had big updates done to them. And one thing I have noticed, I don't know whether or not the way you've done the app or changed the app, but the signals are a lot larger in the screen now. You get the banana shaped signals. True. They're a lot larger. So is that because they're far more sensitive, or what?
So I should probably make it clear at this point that I am not a gravitational wave astronomer.
Imposter!
I am in no way part of the LIGO Virgo consortium. But from what I've heard, they've made the detectors a lot more sensitive, especially to low frequency signals. So the reason that you're seeing such big kind of areas of kind of likelihood of where the object is in the sky is because they've made the detectors that much more sensitive, and you can see much more.
They're a lot larger, yeah.
Yeah, you can see much more, much further and much lower frequency signals coming on the.
Right. Because another thing I have noticed is the type of objects have changed in the latest observing run. So there does seem to be a lot more terrestrial noise, which might be a function of the increased sensitivity.
Yes.
Also, there are a lot of burst candidates as well, which there didn't seem to be before. Do you know much about those? Because it never used to, we never used to see them really in the old CHIRP.
Yes, I mean, this is basically, for those that aren't aware, we don't. There's like an official source for gravitational wave related objects detections called GraceDB, and we do not take from GraceDB. We are sat there watching the gravitational wave. The gamma ray coordinates network. So when a GCN notice gets published by LIGO, CHIRP intercepts it and processes it, and gives you processes the sky maps and then presents it to you basically live. And it's done that ever since it started. We've never used GraceDB. So the good thing about that is CHIRP pretty much always has the latest information, unless something's gone horrifically wrong behind the scenes, which it has done and probably will do again.
Yeah.
CHIRP should always kind of have the latest up-to-date status of all the events.
Right.
Yeah.
Right.
Because
but it does mean that sometimes you end up with preliminary events, and this is what we're seeing at the moment. Actually, I need to do an update to the app. But what we're seeing is because the detector is that much more sensitive, and it's much better at detecting those low frequency gravitational wave signals. It seems to be that they've pushed the false alarm rate or the significance down for the alerts that are coming through, and that's why you're seeing much more terrestrial things that are classified as terrestrial noise.
Yeah, absolutely. Because before you might see 1 in 10 was terrestrial noise, and now it's sort of most of them. Looking at the last couple of days,
it's sort of 50-50, isn't it?
Exactly. Yeah. But the clue is in the FAR, or the false alarm rate, or what some people call the significance.
Yeah,
and that's telling you what the likelihood of that event occurring, how often it's likely to occur is. And so you'll probably see, if you look at the terrestrial noise and some of the burst candidates, you'll see that it's, say, many times per month or many times per day is the false alarm rate. So it's quite a low significance event, really. So the events that we used to seeing in O2 are the really high significant ones, the ones that happen, say, once every 100 years or once every 1,000 or so years, or in some cases several thousand times the age of the universe.
I did see a few. There was an exponential involved in the number of years, and I thought, gosh, that's pretty good.
Because also, I mean, what we must also explain is that when LIGO and all the other detectors detect anything, that they immediately notify observatories around the world, which then, if they've got a free telescope, will then slew to where the signal is supposed to be, to see if they can actually pick up the event in light. And then, of course, using different observatories at different wavelengths of light, you get the signals come through from that event at different times, and it can be over days and weeks. So it's not just we've detected a gravitational wave. It gives the chaps a time, and it's done within minutes. It's before they used to do it before they'd even confirmed whether or not it was terrestrial or whatever. But because I suppose now, because it's more sensitive and they're a bit more confident, they notify them straight away, and they have a look and see if they can actually see the event. And also with the bigger signal on the diagrams, they got a better chance of actually pinpointing where it is.
Yeah, absolutely. And of course, you've got the orbiting observatories like Swift as well. And if you remember GW 170817, the neutron star kilonova, that just, that really ushered in the era of multi-messenger astronomy, because it was observed, it was shoving out EM right across the spectrum, and it was observed right across the spectrum as well. An amazing event, absolutely unbelievable event. I still love talking to people about that. Even people I've never met. I even ring random people in the phone books and talk to them about it. So, I love doing things like that. Anyway, thank you for that information about CHIRP.
Bernard
I have a question. Yeah. I think we need to step back a bit for our audience. How many gravitational wave detectors, observatories do we now have? And how many of those are actually feeding into your app?
That's a good question. So in principle, there are 4 currently online. There are the 2 LIGO detectors, LIGO Hanford and LIGO Livingston, both opposite sides of the United States, to try and get a nice wide baseline between them, so you can do a better job at triangulating where the signals are coming from, where the gravitational waves are actually coming from. You also have the European-based one, GEO 600, which I think is, it's in Germany, and you also have KAGRA, which is in Japan, which I think is offline at the moment. But in principle, they should all feed into the CHIRP dataset. But I think it's only currently the 2 LIGO detectors that are on Sky.
Yeah, I think you're right. I haven't seen anything from Virgo or KAGRA.
Sorry, and Virgo as well, of course. Virgo in Italy.
In Italy, Virgo. Because also the Indian, they're building a
LIGO India.
LIGO India.
And that's going to be huge. LIGO India coming online.
Because I was just reading just a minute ago, because I knew you were coming on, and they were talking about there's going to be of course, you've got Einstein coming on, which is the European one, which is going to be underground. That's going to be a huge one.
Huge deal as well, yeah.
Yeah, and there's a new one that's it's in the planning stages as they are, and it's called Cosmic Explorer, and the arms on that are going to be 40 kilometers long. So that's going to be absolutely huge. Because I think LIGO are 4, aren't they? 4 kilometers?
Yeah, something like that.
So it's 10 times as big, and then of course we got LISA.
LISA Pathfinder is going to be exciting.
Which is going to be the space-based one, and that's going to have a huge expanse on its arms, and that'll be, is it 3 satellites altogether?
Yeah.
Yes.
Which they'll probably go out to one of the Lagrange points or something, and then just sit there and receive all these gravitational waves, and CHIRP will be going mad, and hey, go on.
That's the aim. Yeah.
I mean, it's, I think to be in like this as we are, the birth of a completely new science, it's just so exciting. Who knows what we're going to discover?
I mean, it's come on leaps and bounds. I mean, it's one of the things that amazes me about the LIGO detectors is they had trouble stabilizing the mirrors, and they're actually using glass strands to suspend these mirrors at the ends of these tunnels for the laser to hit and then come back, and it's literally just strands of glass that are supporting this mirror.
And do you know what? A lot of that work was done at the University of Glasgow, and they continue to supply parts for LIGO, and they had to invent a completely new method of welding glass onto the mirror to join those fibers onto the mirror. I mean, it's amazing. It had never been done before, welding glass in that way. So, really cutting edge. And all of these new technologies find their way into industry and into everybody's lives eventually, So it's all money well spent. So there we are.
Sam, I have another question for you. For our viewers again, how many detections do we have per day that is being reported on your app? And going forward, maybe the Japanese detector is going to go back online or whatnot. How many do you anticipate?
That's a good question. So I think, at the moment we can get, depending on the uptime of the detectors, anywhere up to 10 or 15 alerts per day. But I've had conversations with people in the know, and they say that really we should be trying to filter some of those alerts because they have low significance. They're not kind of they're not the quality of alert that you'd expect to be seeing, and we definitely shouldn't be sending push notifications out for them. So I think I would expect if you don't if we kind of filter the significance on them and actually kind of take them to the significance level that the O2 was running at, I expect we'd have far fewer. Maybe.
I mean, would it be possible
to what we saw with O2?
Yeah, would it be possible to just filter out the terrestrial noise ones altogether? Because nobody's interested in that, really.
And that's probably what will end up happening when we put the significance on it. Is it will just filter out the noise, and maybe a few of the less significant burst candidates.
Sure. Yeah. Because when we talk about terrestrial events, I mean, it could be traffic, earth tremors, but equally, such is the sensitivity of LIGO in particular, it could be waves crashing on a shore a few hundred miles away.
Yeah, exactly. It's. I've spoken to my to my friend and colleague, as I said, Sam Cooper, who was working on the seismic isolation systems at LIGO for his PhD in research, and he was just the amount that he had to deal with. Someone walking along by one of the arms a mile away from it was enough to knock it out of lock. It was insane.
It's insane.
Yeah.
Roger, you had a question.
Well, they all seem to be at a similar latitude. So is there nothing in the southern hemisphere that would help?
I think there's been suggestions to try and build one in the southern hemisphere, but I don't think anybody has kind of supplied the funding for it yet.
All right.
So I mean, there is work going on. I think at Osgrav in the States. Sorry, not the States. In Australia.
Yeah, they're too busy building the SKA. So
you just took the words out of my mouth. Literally, they've got their own projects that they're dealing with.
Oh, don't give us that as well.
Yeah. I think I can remember at one time I saw a documentary and they were talking about one of the LIGOs, and about 4 or 5 miles away there's actually a train line, and what they have to do is they've got a timetable pinned to the wall so they know not to do or to take any notice of detections when the freight trains go past about 5 miles away.
It's crazy, absolutely crazy. All right, we need to be moving on as time is as ever against us. Sam, we'll take a break for the news, and then when we come back, I'd like to talk about your other work with astrophysics and light pollution.
Yeah, sure, no problem.
Okay. Right then, so let's have a look at the news for this week. It's been, as we said, quite an historic week with as far as OSIRIS-REx returning the asteroid sample. But there's also been lots of other stuff going on, including a really weird story that I can't wait to tell you about. So let's bring up the news. Just give me 1 second to get into it. Okay, so here's the news. Let's have a look at the asteroid return, asteroid sample return. We won't show you the actual thing landing because the quality of the live coverage from NASA was just appalling. We had difficulty making out the return capsule against the background of the desert. It wasn't very good at all. So let's join it just as the first people are approaching the capsule.
Stu Wiley, our on-scene commander, and right behind him is Victoria Team. They're both wearing personal protective equipment, gas masks. That's for their own safety as they approach, as there could be potential outgassing from that sample return capsule's batteries heating up during re-entry. You can see him scanning the region. He is checking for any possible unexploded ordnances, UXOs.
Performing an exploded ordnance survey.
And you just heard that he is in fact doing that survey right now. You can see him walking around the SRC. This is the first person to come in contact with this SRC since it was on the other side of the solar system. We had sent this on a long journey. The OSIRIS-REx spacecraft. Finally delivering the sample, he is motioning over to Victoria Team, who is shortly going to approach and begin taking some gas and thermal readings. You can see her walking over and must have given the clear for her to proceed.
And let's now have a look at the moment the sample entered the clean room.
And place it onto the clean room. Little transfer.
So there it is. You can see how black it is after its journey through the Earth's atmosphere, and being carefully pushed into the clean room.
about to be moved off onto our clean room fixture. The clean room team members carrying that SRC in, and these doors will be slammed shut just as soon as we can get that SRC fixture out. And there we go. It is in the clean room, the SRC from the desert of Utah. Earlier this morning arriving has been successfully delivered to the Dugway port.
So there you are. So that's the SRC, or the sample return capsule, being placed in the clean room. It will go to the Johnson Space Center, and from there it will be distributed in good time to the world scientists for analysis. Very exciting times, and
Yeah,
of
it
course,
certainly was.
yeah, absolutely. Just a reminder that asteroid Bennu is classed as a very dangerous asteroid, because there is a non-zero possibility of it hitting the Earth. The next time could be as soon as 2182. Not that we'll see it, of course, but we need to know more about this asteroid, and as a bonus, learn more about the early history of the solar system and the formation.
Don't worry when it does come in that time, because hard hats will be issued.
Oh, that's fine. That's fine.
So because one of the things that just made me giggle is when that chap approached the capsule, he said he's the first person to approach the capsule since it was on the other side of the solar system. I think it was a bit longer than that. I don't think there was anyone around at Bennu.
No, no, true.
Yeah, but there have been some quite comical errors as regards to the report.
Oh, yeah, like the Washington Post saying the capsule had taken 4 hours to return from the asteroid.
Yeah, exactly. Tried 2 hours, 4 months. 2 years, 4 months. Sorry.
Yeah, that's right. And of course the capsule being the size of a car.
Oh, that's right. Yeah.
A Hot Wheels car, obviously.
Yeah.
There have been some really, really astounding press errors this week. Anyway, let's move on.
Can I just remind everyone that that the Japanese have done this twice already? First,
yes, indeed,
with Hayabusa 1 and 2. So
we may talk about that in a minute.
Yeah.
So.
Okay, let's move on to the next story. Bernard, do you want to say just a few words about this, the discovery of the CO2 on Europa?
Yes, totally. So the ocean under Europa is one that is clearly mysterious to us because it's completely locked, as opposed to the one in Enceladus, which is venting off plumes of water, and which we have already sent Cassini through it to investigate. Whereas the ocean under Europa is still extremely unknown as to what it is. What is it made of? And it seems like we have found some, or the JWST did a 10-minute observation and found that there seems to be a detection of CO2 on one of the chaos regions of Europa. And chaos regions are, on these sort of ice plates where there seems to be some of the ice that has been moved around, and it seems like the CO2 has been coming from the subsurface ocean. Now, carbonated water is not new. Our ocean has carbonate, has CO2 within it, and increases, and that level will increase with global warming. However, it does indicate that there are carbonated rocks, most likely. Another source of CO2, of course, is volcanism. So there, it's a great window within the subsurface ocean of Europa.
Yeah, absolutely.
It certainly is.
Yes, and of course, once the Europa Clipper arrives, and JUICE, of course, both studying both studying Europa, we will hopefully find out a lot more. But we've got a few years to wait for that. But,
because most of the CO2 that they've detected with the JWST, it was in a 1,800 kilometer wide, or that's 1,120 mile wide area called Taro Regio. And as you said, that's in the chaos terrain.
Oh, yes, that's right.
Yeah, and they have been looking to see if they've been able to detect a plume. I don't think they've had a good chance.
Because that plume that Hubble detected, there's been a bit of doubt over whether it actually did detect it, didn't it? There's a bit of doubt.
And it was in another region. It was not the same region.
No, that's right.
Right. But look, we still, the plumes are, the evidence for plumes are still out there. That's, as you said, where Clipper is going to come in. But hopefully JWST might be able to find a way to detect potential plumes again. So
Absolutely.
Again, it's just showing that JWST is doing a fantastic job in planetary science. And I mean, just look at this picture; it's fantastic.
It's amazing. And as always, if I might just give a plug for the excellent sci-fi film Europa Report, which is the story of the first humans to land on Europa. It's a wonderful sci-fi movie made in 2013. It's a fairly low budget movie, but I loved it. I absolutely loved it. So there we are. It's the story of what happened to the expedition, and it's not what you think. So there we are. No aliens involved, much. So anyway, let's carry on with the news.
Someone die at the end, Andy?
Sorry?
Does someone die at the end of the film?
I'm not saying a word. I'm not saying a word. You'll have to watch it and find out. But it's a great movie.
Yeah.
Highly recommended. Okay, now this is a weird story. There's a company called Lone Star, and what Lone Star are doing is this. What about mankind or humankind's most precious data that we don't want to lose, that we just cannot afford to lose? So, this could be anything from government records to whatever. Lone Star are a company who have had the idea of transporting the data to the moon and storing it on the moon. So, this could be really important stuff that we don't want to lose. So that sounds an interesting idea. Some people have said, well, why don't we just store it at the bottom of the oceans, which is a bit nearer if we need to get at it. But they think that, lunar storage is the future, basically. That's what they're saying. Now, what amazed me about this, and I swear this is true, would you like to guess which, well, I'm not going to call it a country, which state? It's not even a state. What is it? Oh, I know what it is, but it'll give it away. Okay, there's an island that is partnering with them to be the first island to send data to the moon with this new storage. Anybody like to guess what the island would be?
Isle of Wight?
No. No.
Greenland or somewhere
Hawaii?
like
No. Oh, anybody else? Anybody? Any other guesses? You probably wouldn't get this, and it's the least likely of all the islands to partner with Lone Star to send precious data to the moon to store it. No.
Oh, I know. It's England, Great Britain.
No. No. All right, I'm going to give you a clue. You'll know this instantly.
Isle of Man.
My
I
God.
was going to say the Isle of Man. No, that's a
You
bit
went that
too.
far for the Isle of Wight.
Yeah.
The Isle of Man is printing special postage stamps that are going to be sent to the moon on the first spacecraft to be stored there to try the system out.
Oh, okay.
Which I found totally bizarre. So well done, Isle of Man. We're all behind you on that.
Yeah, well done.
Yeah. So, but
So they've got a space agency, have they?
Well, this is what we need to investigate, obviously,
Yeah.
because just to tell Sam, we're doing a new series of videos here on Space Oddities called Rockets Away, where we're going to tell our viewers all about the latest spaceflight news. But we're also going to pick one international space agency per week and do a profile of it. We're starting alphabetically with Algeria soon when we get it recorded. So perhaps we can look into the Isle of Man, Daz. Make a note. That's your homework for tonight.
Yeah, have a look for the Isle of Man.
Yeah, okay.
So, that is. Did they actually go in to say what they're going to store this information is? Are they going to build a habitat or?
No, it's going to be, as far as I can see, it's going to be stored in landers, just the landers on the surface. But there's not much information at the moment, so
They're just basically fly tipping all the old files.
Yeah,
all
basically.
The old files fly tipping.
Yeah. Okay. Well, moving on to the next story. Who remembers DART? I thought we'd do a little bit about DART because it's a year since DART.
Yeah.
If you remember DART, the impact with Dimorphos, the asteroid, to see if the impactor, a spacecraft, could deflect it in its trajectory. And this is the first attempt, really, to experiment with planetary defense. And this is what it looked like. If you look at the top right-hand corner, it tells you how long after the collision we're looking at. I'm sure you remember this from last year.
Yeah.
You see that what happened at Dimorphos was entirely unexpected. We had this sort of comet-like tail of debris that the impact threw up, if you like. This is looping, by the way. And all I wanted to say about this was that they managed to change its orbital period around its parent asteroid, because it's a binary asteroid. The other one is called Didymos. They managed to change it by 23 minutes. They changed the orbital period of Dimorphos around Didymos by 23 minutes. Now, this was far more than anybody had expected, but something else happened that was a bit strange. Over the next month, it lost another second off its orbital period, meaning that it was actually taking longer to go around Didymos. Now, that's the first thing. Now, recent measurements seem to indicate that, in fact, Dimorphos is now tumbling in its orbit around Didymos, that the impact seems to have had some weird effect that has caused it to tumble where it wasn't tumbling before. So these are, completely unexpected results from the impact. Nobody expected things to be so complicated. Nobody expected this debris that you're seeing, especially not the sort of the bright cometary tail that went on for, shot out a long way into space. So the impact basically didn't happen in the way that we thought it did. And in terms of surface constituency, it's thought to be very much like Bennu, in fact. And I think if you remember the images panel, do you remember those close-up images when the impactor was getting close to Dimorphos? It did indeed have that sort of rubbly, gravelly surface that we saw at Bennu. So what's going on here exactly? Nobody knows. Why it lost another second off its orbit, or gained another second on its orbit, I should say, in the month following, and then calmed down to normal. Why it's now tumbling, it's really weird. We really don't understand the dynamics of systems like this yet. Anyway, just thought I mentioned that. Many congratulations to the Ingenuity helicopter on Mars. It's just done its 59th flight, would you believe? And it's achieved a new altitude of 20 meters, which is a new record for that little helicopter on Mars. There's a shot from the 59th flight. It's a selfie of of Ingenuity's shadow on the surface of Mars. And well done, engineers behind Ingenuity, because they didn't think they would get 5 flights out of Ingenuity before it succumbed to the Martian environment. And it's now on 59. So that's fantastic news. So well done to NASA and everybody involved in that. The James Webb Space Telescope has produced this amazing image. This is a gravitational lens of a supernova, and you can see the supernova 3 times in this image taken by the James Webb Space Telescope. Scientists are really excited about this because they've never seen a supernova this far away in any detail. And they hope it'll help to resolve the so-called Hubble tension, the weird thing that's going on at the moment with variations in the expansion rate of the universe, depending how you measure it. Supernova being one method, and the cosmic microwave background being the other, of course, that they use, and they don't agree. So they're hoping that studying this image will perhaps help them to pin down exactly what's going on with this anomaly between the 2 different methods of measuring the expansion rate of the universe. It's certainly a big problem at the moment in cosmology. Anyway, just thought I'd show you that. And just to finish, some bad news from the moon. The Chandrayaan-3 lander, which you remember we covered when it landed, and it spent 2 weeks in the lunar day and then went into the lunar night. Well, Indian scientists were hoping that it would wake up after the extremes of the lunar night. And since lunar dawn, they've been trying to communicate with it, and they've had absolutely no luck. So it looks as though the lander and the rover may have frozen and died. And in fact, it may be the case that some of the subsystems on both are still working, but the communications equipment isn't. So the lander and the rover can't actually tell anybody that everything's working. So what India's going to do, they're going to wait till the end of the lunar day, and if they haven't obviously received anything from it or managed to communicate with it by the end of the lunar day, then they're just going to say, well, that's it. Bye bye Chandrayaan, thanks for all the fish, and that's it. It'd be very sad, but it would be a monument left on the moon to the fantastic success that India had putting it there in the first place. So that is the news for today.
But haven't the Indians also joined up? Is it with the Japanese to send another lander?
Yes, they
soon?
are sending a joint lander, so that'll be an interesting project as well.
It should well be, yeah.
So there you are. Okay. So Sam, can you tell us a little bit about the work you're doing with astrophysics and light pollution?
Yeah, absolutely. So when thinking about light pollution, you might quite rightly be asking, why should I honestly be concerned about light pollution? I mean, obviously, present company well aware that astronomical observations are very seriously affected it, but it has all kinds of other impacts as well. And when I'm talking about light pollution, I'm referring more generally to something called artificial light at night, or something that's shortened to ALAN, which encompasses several hundred million streetlights all over the world, nearly the 1 billion passenger cars from all over the world, the several hundred million commercial vehicles, and nearly 4 million fishing vessels, and all of the other public, all the other private indoor and outdoor lighting. So we're trying to basically account for all of this when we're talking about artificial light at night. And it's well documented in the literature that it can have very serious human effects. So we're talking about blue light at nighttime, such as that you see in modern LED lamps, reducing the quality of sleep and the length of sleep because of melatonin production being suppressed, which can then have ripple on to other health and well-being problems, including immune function and eventually potentially cancer as well. That's ignoring all of the environmental and ecological impacts from the manufacture of lighting devices, and the fact that I think between 17 and 20% of global electricity production is to actually use in lighting, with about 2.3% or so of that being public lighting, mainly in street lights. So we're talking about big, a fairly sizable impact for artificial lighting. So I'm part of a project that's between the Astrophysics Group in Exeter and the Environment and Sustainability Institute, and we are using a technique, or we're using a modeling technique called Monte Carlo radiative transfer, which is a technique that was originally designed for astrophysics to model and make synthetic observations of the beautiful nebula that you can see behind all of you.
Oh, really?
So yeah, the technique is used in the astrophysics group in Exeter for studying, among other things, the formation of stars and the disks that form around them. So in star formation, in planet formation, and modeling both how the radiation transfers from the star to the disk and the surrounding molecular cloud and the feedback that's caused by it, as well as simulating observations of those disks and kind of backing out from observations from interferometric measurements what the original disk, the planet, the like the protoplanetary disk around the star would look like. And so we're taking this technique, which is also used in diagnostic radiography and medical imaging, to essentially reconstruct digital twins, digital models of, at the moment we're working on streets, but we're scaling up to the university campus and then the city of Exeter, and we're simulating all of the light sources in the environment, as many as we can get our hands on anyway, and basically simulating them by sending photon packets out from each light source in the environment, and letting them move through the environment as a real photon would do.
Wow.
So we're doing like a radiative transfer treatment to simulate where the photons would end up in the environment and what ecological impact they have, both for animals and humans.
So has work like this not been done before then?
So that there are other models out there, but they tend to. So I mean, the ways that you can get at this information is via like a backwards method, such as looking at satellites. So you can take satellite imagery of nighttime areas, but the problem is that then you're looking down on the environment, so you're only really seeing what's reflected up from the ground or what's emitted directly upwards. So you're not getting the full three-dimensional distribution of the light in the environment. You could also, if you wanted to get a little bit closer, you could use things like drones or aerial photography from planes, but they can be really expensive to run and legally often problematic to actually fly at nighttime, especially in urban environments, right? Or you could just go, say, into the actual area itself, which we have been doing in Exeter. So I earlier on, as well as being an astronomer who goes out into odd places with my telescope, I was thinking of the area, the night skulking around the city of Exeter with like a DSLR camera on a tripod, kind of measuring the lighting environments, and I had some very odd looks then as well. So I was sympathising with your police remark earlier on. But going into the actual area is really, really difficult, time-consuming, and expensive to do for kind of large areas like a city. There are other ways of modelling, like the lighting environment in the area or the sky glow, but they tend to not be 3D, so they only give you like a reflections off of surfaces. They don't tend to treat kind of high-order optical effects such as refraction, or scattering in the atmosphere, and they tend to be optimized for kind of kilometer-sized spatial scales.
Right.
So we're basically at Exeter, we've developed a method that we can do 3D simulations of the lighting environment at and just above ground level on, say, meter scales, on the scales that humans and animals actually experience the environment. So that's kind of the thing that we're adding to this field.
Right. So could that same technique theoretically be applied to anywhere on the planet?
Yes. Yeah. Exactly. That's the aim. So we're just using say LIDAR data, which is fairly readily available for the rest of the world. We have building footprints that we can build up, say the buildings that are in the environment. We're using photometry, so like the direction that each light source emits in, the amount of light it sends off in different directions, the spectrum of the light, and we're basically modeling probabilistically all of these effects in the environment, but we can, in principle, switch it out for anywhere. So we could, say, go to a completely different city or a completely different country.
Okay.
Oh, fantastic.
Well,
Yeah,
that sounds absolutely valuable work.
Yeah, sorry about that. We were talking about it before we came on air about light pollution, and we were discussing a small city in the USA, which is next door to a large wild area, a national forest, and they passed an ordinance where they were going to replace all their street lights with LED lights to try and reduce the light pollution. And they did this, and they spent all the money, because also they said it will save money going to LEDs and things like that. But for some unknown reason, in their infinite wisdom, they decided to get the brightest LEDs they could find. And of course, they fitted all these to the street lamps, turned them on, and they had an image of the light dome above the city from a vantage point a few miles away. And when they turned on the lights, they found the light dome had actually grown because the LED lights had increased the light pollution. And it was just one of these things. What you think you're doing good, but sometimes you can be doing, the opposite of what you did. Instead of using the lower level LEDs, they used the high ones, so it backfired on them. But it is a problem that needs to be recognised as for ground observing of astronomical objects, and so Yeah, more power to your elbow. More power to
Yeah,
your elbow.
yeah, best of luck
Yeah.
with that. And
The LED thing is a thing that we're seeing the world over, right? I mean, luckily, we've been working with the council in Exeter. Luckily, they're doing a fairly sensible thing moving forward. They're replacing their lights with much lower power LEDs, so you kind of get a roughly similar amount of power emitted from the lights in the end. They're still a little bit brighter, but they're doing a very sensible thing. They're replacing with lower level lights, but as far as I can tell, that's not the case elsewhere in the world. That's very much a local thing.
well, the LEDs here in Catalonia, as I said to you in an email earlier, that Catalonia and the Czech Republic are the only two places in Europe that have actually introduced legislation about light pollution. So all of the streetlights here have to be hooded. And they have in our village, and I think it's throughout Catalonia, they've got a program to replace all of the old sodium with very low wattage LEDs. And our village is noticeably darker now.
That's good.
And it's good. But of course, you've still got the problem of outside lighting. So, the church has still got these huge searchlights shining up at it at night. And, that's another problem. But,
Yeah.
And also, they light up that roundabout with the lady with the big boobies.
Yeah,
so
we won't
will pause
the
it.
fallen
We
Madonna
go
with
past
big
that.
boobies. Yeah, we won't mention her. Yeah, but they've lit up the lady with the boobies with these very bright blue lights that shine upwards.
Can we move away from the lady with the boobies? I'll talk about the complete opposite of Catalonia, and Sam, maybe you should do this. I come from Belgium, and in Belgium it's the complete opposite. Every single street has had to have street lighting. Every street, every road, every highway, everything was just street lighting everywhere, and that was a policy that was set up in the 1970s. And the night sky has just been not black at all in Belgium for so long, and only now they're starting to switch them off because they want to do some savings. I just really wish that these type of studies you're doing would actually show if not the damage, at least the impact this is having on the environment and for people in general.
I mean, that's exactly the aim of what we're trying to do. So we've recently presented at the big international light pollution conference in Canada, and I've literally last week we submitted one of our first big papers from the project, and in that paper we show essentially that there's no, that, as you've said, that there's the idea that switching over to LED lamps is like the way to solve the problem. And we basically show that's not the case. There's no single light that is better than any other kind of light. So we test kind of high pressure sodium, we test metal halide lamps, and we test LEDs that are roughly similar power in the same environment, and they all have a trade-off to them. So to kind of summarize it, the LEDs are better able to focus the light along the road than the others, because, as you say, they have better shielding, they have more advanced optics in them that can focus the light better onto the environment that they're aimed at. But because they're designed to basically throw the light along the road, to light as much as they can with high uniformity, they actually end up making a consistent barrier along the road. So if you're a photophobic nocturnal species, such as in our case a hedgehog or a bat or that kind of thing, you would be kind of blocked from going through this environment because it'd be too bright. You'd be scared, and it would change your behavior, which can cause big ripple-on effects in other parts of the ecosystem. So there's no golden bullet here. There's trading things off with different kinds of light in the right place at the right time.
Yeah, it started a conversation in the chat. Astro Nebulae says, very interesting, Sam. I contacted our council and they are running a study to see if we will dim if they will dim the high street lights and turn off others after midnight. And that's what happens here in our village. After midnight they go off. but they are also well hooded in our village, I must admit. He said he's managed to get two
Well done
shielded,
indeed, Astro.
which is well done. That's good.
Congratulations.
Then
Great work.
Ian says, Thieves' Paradise, dark villages, towns and cities, great for astronomy though. And Andy did reply to that. So
that is an interesting question.
Yeah.
So I mean, I'm not incredibly familiar with the literature around this, but I've seen multiple studies that kind of debate how safe extra lighting makes you. I think it gives you the perception of feeling safer, but I don't know if there's actually figures to back up that.
No, because what we find is that people install these security cameras, but after the novelty's worn off after a week or two, they don't check. If the light goes off, they don't bother checking, see if there is someone in the car.
And what do those security lights do? They just show the burglars where your doors, windows,
where doors and windows are. And remember, if the burglars have got to use torches, we're going to notice them more. So, it swings and roundabouts, isn't it? Industrial areas are one of the worst as well.
I've always said as well, a lot of women are fearful of going out at night for fear of being attacked. And they obviously want more light, but I take the opposite view, because if you're in pitch darkness, your attacker can't even see you. I think you're less likely to get attacked in a dark environment than you are in a brighter environment.
Yeah,
maybe, I don't know.
Exactly. I mean, you have to remember that humans, much in the same way as other animals, are animals. We are our behavior is determined by our environment. So if our environment is dark and we don't feel safe, we won't go out. We won't, we will avoid the environments in the same way that animals might avoid a bright environment because they don't feel safe. So we need to be kind of careful addressing how saying people do or don't feel safe, because at the end of the day, it is also it changes the behavior of humans as well.
Exactly. I mean, because our ancestors at night time would stay close to the fire, because that was where the light was. But it's because Ian's just put car alarms are the epitome of this. Who cares? We just get annoyed.
Which is true. That's true as well. If you hear a car alarm going off, you think, "Oh, for God's sake, turn that bloody thing off!"
Exactly.
You don't go and investigate. So, you don't ring the police. So very true, Ian. Very, very true.
Can I ask
But are you optimistic, Sam, about large scale on this planet that we can address and perhaps solve this problem, or just mitigate it? Because it is getting worse, isn't it? I mean, for all of the good efforts put in by people like yourself and us, and when we write to our local councils and whatever, it's a growing problem. Can anything be done?
I mean, yes. I mean, we can. The good estimates say that the amount of light, both the extent of it and the amount of it, is growing by about 2.2% every year. So light, artificial light at nighttime is getting worse. The extent of it is getting worse. But we can all. The beautiful thing about the problem is that we can all do our bit if we have lights. Dark Sky International, the international body for kind of helping encourage dark skies, has a checklist that you can go through if you're replacing your lights. So it's stuff like, is this light really necessary? Can it be shielded? Can it be dimmer? Can it only be pointed towards the thing that's important? Can it not trespass into the environment? So we can all do our bit by, as Astro was doing, talking to the local council, by looking at our own lights and checking whether they kind of meet the Dark Sky International checklist of what a good lighting source is, and just by being aware of it and talking about it when we see it.
Yeah, absolutely. Because you're right. We can all do our little bit. The problem is when you try and get in touch with local councils, they don't understand the problem, and it's not high on their list of priorities. It's probably the lowest thing on their list of priorities. But we have to try. It's the only thing we can do.
Can I just finish off maybe with a ray of hope by saying that now everyone has a torchlight in their hands, aka their smartphone. That could potentially alleviate some of those issues that people might have when they go through a dark alley or dark street. That they can always use their phone to in addition to light the area, but also call people if they feel insecure. So I don't know, that might be a way out of this.
I use mine frequently when I'm walking home in the evenings through the forest, because of course it's absolutely pitch black, and the only thing I'm wary about is wild boars who've been known to jump out in front of me, which is quite frightening when you're not expecting them. Everybody's got those on them. These little lights that provide more than enough light, for walking. So let's hope so. All right. Looks like time's against us. Daz, could we hold over your presentation until?
Yeah, it's only just sort of like
okay.
If we need it. But I would just like to say I've just had a notification from space.com, and it's a James Webb images, and it's showing the earliest galaxies that they've actually caught, the shape of them, and it's little thumbnails, and it's all different, and there's a lot of spiral galaxies, which of course we weren't expecting.
No.
I'd advise you just to have a quick look if anyone fancies it. I've just had a notification now, so it's only just literally come through.
You don't have permission to leave us before the end of our show to go and look at that. You have to stay here and watch us.
Yeah, of course. Yeah.
Otherwise, I'll send a note to your mothers.
Yeah, if you leave early, it's truant.
Yeah, absolutely.
But there's some interesting structures there, really.
I'll go and have a look at that.
I think there's even some bars.
Perhaps we can put that in next week's news then.
Yeah, there's even some.
I'll have a chat about it. Yeah. It's actually about time we had a big chat on this show about the first year and a bit of James Webb, because I'm sure we've all got something to say about it. It's been an amazing year, and of course, bearing in mind that because of the fantastic job done by the ESA in putting Webb on the correct trajectory, it may have 20 years of life.
Yeah.
And we're only just over the first year. So what on earth is the Webb going to discover over the next unbelievably couple of decades? So
we're actually putting together. I'm editing at the moment a video for our Astro Group page about James Webb and the early release science team that are working on direct imaging. And the Professor Sasha Hinckley, who's doing the video with me, said at the time that some of the estimates he's heard are actually 25 years.
Really?
So it could actually be still, it could have, what was it? He said 25 years worth of petrol in the tank, as it were.
Wow.
So it's amazing just seeing how well that launch went and how it ended up having such longevity when some of the estimates were 5 to 10 years, right? So.
Yeah, absolutely. And of course, the biggest enemy during that time is going to be micrometeoroid impacts. That's one thing that could scupper the whole show, because they've already had one, haven't they, on one of the mirrors, which didn't affect it, but it could be something bigger next time. But it's in the lap of the gods. We just have to enjoy the results while we've got them, I think.
Yeah.
So there we are. All right then. Well, listen, I think we'll draw things to a close for this evening, unless anybody's got anything else they want to talk about. Well, not anything, I'm not interested in what you bought at the supermarket today, but anything, unless it's interesting, of course.
I've got a verruca.
Have you got a verruca, have you? Right, okay. I asked for that, didn't I? Yeah.
I didn't know it was no holds barred, okay.
I had my hair cut today.
Yeah.
What remains of it?
I was going to say it was a stock take, wasn't it?
Yeah. Oh dear, laugh! I nearly brought around. Okay, listen, I'd like to say a big thank you to Sam for being here. Sam, it's been fantastic.
Thank you, Sam.
Thank you, Sam.
Thanks very much for having me.
We hope that you will come back and talk to us again in the fairly near future about your work with light pollution, because it's something that, going by what people have been saying in the chat tonight, is interesting a lot of people because it affects everybody. Ian says, can we talk about string theory? Ian, we'll save that to another day.
If you're an expert, go on then, Ian.
Yeah. I mean, we're not talking about vests either. So there you are. Yes, so Sam, please come back. In fact, you're welcome to come back any Tuesday, Sam. Just drop in. You've got the link. You're welcome anytime. Just hit the link and just drop in. You're more than welcome to do that if you'd like to join us. But you did say that you're shortly publishing some papers about your work. So perhaps when they've published, you can tell us a bit more.
I'd love to. Yeah, it'd be a pleasure.
That was fantastic. Well, we will
Look
keep in
forward to
touch
it.
with you, but as I said, you can drop in any Tuesday and just join us on the panel. And there we are, Steve Warbis. Steve Warbis used to be on the panel, but he's been having he lives somewhere really, really remote in darkest Wiltshire, isn't he? And yes, and he's had trouble connecting. But Steve does say, where we are. Thanks, panel. I'll leave it. Thanks. Great show tonight, as always. So from Ian, Steve says, got the wrong one. Where's Steve's comment? Oh, there. Steve says, thanks, Oddies. Great show again. Particular thanks to Sam. Gerard says, thank you, guys. Great show as always. And so on and so forth. So thank you so much for being here, Sam. It's been most interesting. Good luck with everything, and we will continue to be avid fans of CHIRP.
Yeah.
And let's hope those terrestrial noise alerts can get filtered out at some point. So,
We're working on it. We're working on it. Trust me.
good man. Love to hear it. Okay, so thank you, Sam. It's been great. All right then. Thank you, the audience. I'll just give you one more chance before we go to buy us a coffee, of course, and we will be back, of course, next week. We haven't got any live events this week, have we, Daz? Not this week. Next
Not
week.
that I can think of it the next week. Yeah.
So what is it? 26 today. So that's oh god, I don't know. When's the 5th? Tell me. Somebody got
It's
a calendar.
after the 4th.
Yeah.
Steve says he's not Wiltshire, it's
Tuesday.
Wigan. So it began with W, Steve. It's close enough.
Of course it is. Of course it is. Yeah, I knew it began with W. So there we are.
Andy, the 5th is Tuesday.
It's a Tuesday, so it's a week on Tuesday then, isn't it?
Yeah.
Ooh.
Yeah.
No,
Yeah.
No,
So
no,
two weeks
no.
today is Psyche.
no, I got it wrong.
Oh,
I got it wrong.
what a surprise.
Oh,
It's Thursday.
Thursday.
I was looking.
Space Oddities
Thursday.
calendar, was it, Bernard?
Yeah.
Yeah. The Space Oddities calendar.
Strikes again.
I had to end on a high note here.
Yeah. Okay.
Yeah.
So is it? Are we saying it's a week on Thursday? Is that what we're saying?
That is correct.
Right. So in other words, we will be well, depending, if it doesn't happen in the middle of the night, the launch, but we'll do our very best to cover the launch live. We'd love you to join us for that, and because we do enjoy doing the live stuff, space launches, and watch it with us, because as you know, if you go to any of the big sites to watch these live launches, and you try and type something in the chat window is moving at 300 miles an hour, and you can't see anything, and you can't read anything that anybody's actually written because it's moving too fast. But here we don't have that problem because we don't have thousands of people joining. Perhaps one day. Anyway, from all of us here at Space Oddities, say good night, guys.
Good night, guys.
No, you
Good night.
And we will see you back here. Not sure what we've got planned for next Tuesday yet, but we'll come up with something for you for your delectation and delight. And until then, have a fantastic week. Take care of each other and be good. And if you can't be good, be average. So
I think next week it'll be origami, a solar system.
Yeah, and your Veruca.
Yeah, my Veruca.
Yeah.
I'll have pictures. I'll have pictures.
Yeah, photos, or you haven't got one. Yeah. All right then. So from all of us at Space Oddities, take care, and we'll see you next week. Bye-bye.